Okay, this is the Wednesday, 5th of November 2014, the non-calculator paper from Edexcel. This is the higher paper. Question 1. Using the information that 6.7 times 52 is 348.4, find the value of the following. These questions come up more and more frequently these days. There's a few ways of doing it. You could have a look at it, because the answer is going to be something like the one they've given you here. So I might be tempted to look at this and say, well, it's nearly 6-ish times 500 is 3,000. So the answer is going to be in your 3,000 somewhere. The other way you could do it is to notice that the decimal, that 6.7 stays the same, but the 52 gets a factor of 10 bigger. So you can make this a factor of 10 bigger by moving the decimal point over there. So 3484. The next one, again, you could do around 60 times a half, so that's about 30, so it's going to be 34.84. Or you could look at where the decimal point moves to. So it's a bit trickier on this one because it moves on this one and on the other one as well. The other one, it's dividing, but the numbers in the answer are still going to be roughly what they were. Well, roughly what they were here, just different factors of 10 out. The answer is going to have a 6 and a 7 in it somewhere. And the way I looked at it was, well, how many 5s go into about 3,000? Well, it's 600. So the answer is going to be around 600, so it's got to be 670. Question number 2. Karen got 32 out of 80 in a maths test. She got 38% in an English test. She wants to know if she got a higher percentage in the maths or in English. What I've done is change 32 out of 80 to a fraction. I've simplified it to 16 over 40, just half them. I've simplified that to 4 over 10, so I've divided top and bottom by 4. And then I've not simplified it, I've found the equivalent fraction over 100, so times top and bottom by 10 to get it as 40 out of 100. And 40 out of 100 is 40%. Because it's a non-calculator paper, I think that's the most efficient way of doing it. So she got a higher percentage in the maths paper because she got 40% compared to 38%. Question number 3. Stem and leaf diagram. I've done what I normally done. I've already done it, but I go and cross them off as I go. So have a quick look at it. There you go. That's what you need for your 3 marks there. You've got your stems, you've got your leaves. I've not left any out. They're all in order, and there's the key. So that would be 2 marks for that, 1 mark for the key. Next one. Kalinda buys X packets of currant buns and Y boxes of ice buns. So there are 6 currant buns in a pack of currant buns. So I've done 6x because it says currant buns is X, and there's 6 in a pack, so I've called that 6x. There's 8 ice buns in a box of ice buns, so I've called it 8y because ice buns is Y. So there's nothing clever I've done there, nothing amazing. It's just if currant buns is X and there's 6 of them in a box, so that's 6 lots of X, and if there's 8 in a thing of ice buns, there's 8 times Y. Kalinda buys a total of T buns, so T stands for the total. Write down a formula for T. Well, the total is the number of currant buns she buys, which is 6x, add the number of ice buns, which is 8y. So you just simply add them up, like that. Next one, solve the inequality. This is very similar to solving an equation. First of all, I've taken out the inequality sign and replaced it with an equal sign. Then I've solved it in the usual way. You take 5 off both sides, and you're going to get x on its own effectively, so you divide both sides by 6. So x is 3 over 6, so x is a half. But when you do it, put the inequality sign back in. You could leave it as x as 0.5 or 1 over 2. That's absolutely fine. Write down the inequality. Well, x is greater than minus 3, but less than or equal to minus 4. So there you go. I've got the equal sign for this one because it could be equal to it, and it's not for that one because it can't be equal to it. Question 6. Steve wants to put a hedge along one side of his garden. He needs to buy 27 plants, and each plant costs that much. Basically, you've got to work out how much he spends. So what I've done is 27 times 554 pence. There's my calculation. So the answer is 14,958 pence. Convert it to pounds. So nice and clearly, yes, he does have enough money. And I've just put down there he's got 42p change. When the examiner marks this, if you've written yes and 42p change with some nice workings, they'll simply give you the 4 marks, then move on. you must show some sort of working here as well. You cannot just put yes for the answer, that will get you 0. You must show what you've done, because there's a little star at the top next to the question 6. Question 7, the diagram shows the plan of a floor. There it is. The total area is 138 metres squared. Work out the value of x. So you need to know how long this length is here. This is quite a nasty one. What I did is, it's a compound shape, so I've split it along there. So I've worked out the area of that top bit. So it's 8 by 15, which is 120 metres squared. And if that's 120 metres squared, I know that this has got to be 18 metres squared, because in total it has to add up to 138 metres squared. So that's 18 metres squared. 3 times what is 18? So that's got to be 6. So 3 times 6 is 18. So that's 6, and the whole length is 15. Well, you can work this bit out here by doing 15, take away that 6, will give you what's left here, and it's 9. So the answer is 9 centimetres. And I put show my workings there, I think, and my answer is 9 centimetres at the bottom. If you get that answer there, you've got, you'll get the 4 marks for it, but please show your workings for it like you should do on all of these questions. Next one, there's a lot of writing I've put here, and it is all necessary, I'm afraid, so I'll explain it as I go. It's a functional question, it's got that star next to it. ABC is parallel to this line here, it's fine. We've got GB is equal to GF. GB is GF there, and that's marked on by these things. That just simply means that's an isosceles triangle, so I expect that's going to be useful later. Angle ABF is 65 degrees. ABF is there, 65 degrees. And work out the size of angle marked X. All right, I'll talk you through what I've done. First of all, I worked out this one. Because these two lines are parallel, and you can see I've drawn it on there, there's a Z angle going on here. So that means that is 65. And I've drawn a little arrow, look, it's a Z angle because it's an alternate angle. The next thing I've spotted is this one here, because this is an isosceles triangle, so this angle and this angle must be the same. So this is an isosceles triangle, so this angle is also 65. Now, I can work out this angle here of 50 degrees, because there is 180 degrees in a triangle, so that would make that angle 50 degrees, and there are my workings for that one. Down there, and I've explained it, 180 degrees in a triangle. So the last bit is working out angle X. If you just memorise that for a second, I'll show you the workings down the bottom. There's 180 degrees on a straight line, so 180 take away 50 is 130. And that's my final answer, and it's worth 4 marks. You do need all of those reasons in there, otherwise you will not get the marks for it. So make sure you put them in. They're fairly obvious, but it's just spotting them is the trick. Next one, questionnaires. Jack wants to find out how far people live away from the nearest supermarket. He uses this question on a questionnaire. Write down 2 things wrong with it. Well, I put down 3 things, but you only need to put down 2. The response boxes overlap, because 0 to 2 or 2 to 3. If you wanted to tick 2, which one would you tick? Do not just write they overlap. You must say what overlaps, so it's the response boxes. There's no units on this. How far do you live from the nearest supermarket? Well, 3 to 4 what? Miles, kilometres, centimetres. So it needed some units on it. And there's no box for more than 6 miles or 6 kilometres. So there's 3 things there. Make sure you've got 2 of them. Jack also wants to find out how often people go shopping. Write a question Jack could use on his questionnaire to find this out. How many times do you go shopping per week? The important thing is there that I've included a time scale. You could have had per month for this one. I wouldn't suggest per year, because that's too big a time scale, so per week I think is perfect. None of my response boxes overlap. You've got to have at least 3. I always think 4 is a very good number to have, and I've given myself scope there to go for more than 6, so 6 plus. And that will get you 1 mark for the question and 1 mark for the response boxes. Question number 10. Use a ruler and a compass to construct the perpendicular bisector. Right, the perpendicular means it goes through this at 90 degrees, which is something like this. What you do with this one is a little bit fiddly. You get yourself a compass, and you put it at one end, so put it at point A, and you set it so it's so it meets up with point C, which is what I've done there. And then you draw that line there. Then you do the same thing from the other side. but set it to touches point C, so we'll extend it a little bit. There it is. And then you draw that one there. And you must leave those lines on. Do not rub them out. What you do next is get your ruler, connect up that point with the points where the lines cross, and that is your perpendicular bisector. When I've marked exam papers in the past, students try to do this with pencils and, well, with rulers and protractors and things. You don't get any marks. You must use a compass to get the marks for this one. Ria is going to buy a caravan. The total cost of the caravan is £7,000 plus VAT at 20%. She pays a deposit of £3,000 and she pays the rest of the total in 6 equal monthly payments. Write down. Okay, so what I've done, it's £7,000 plus the VAT. So I've done £7,000, add the 20%. Here's how you work out 20% of 7,000. 10% is 700, so 10% is 700. So 20% is 1,400. Added it up there, so that's the total cost. She pays a deposit of £3,000 there. Well, that deposit comes off. So I've just done a simple subtraction. So it's 5,000, that should be a nice clear 4 there. £5,400, and she pays it over 6 months. So I've just done a bit of long division here. How many 6 is going to 5,400? You could look at how many 6 is going to 54 and recognise it's 9, put 2 noughts on, or you could do what I've done there. But the answer is £900 is how much you'll have to pay each month. Question 12 now. A few back to basic ones here. I've factorised this one. Well, factorise means put into brackets. So you've got to see what's common in 5e squared and 5e. Well, the e is common, so the e goes outside the bracket. So it'll be e times 3e will give you 3e squared. E times 5 will give you the 5e. So 1 mark for that one. 3 marks for this, which is quite generous, I think. You've got to solve it. Multiply bracket, like I've done there. Then I've just started to solve it. So when I solve them, I always get rid of the smallest number. So minus 21 is my smallest one. So I've added it to both sides. So that leaves you with 7k equals 3k, add 16. It's 16 because you've done minus 5, add 21. Gives you the 16. Then you want to get k's on one side. So take away the smallest number of k's. So take away those 3k's. From both sides, so that's why 7k take 3k is 4k. It goes from this side, it's 16. Then you simply divide it by 4, solve it from that one. What you can do is double check this answer and substitute it back in to make sure it does work. So I'll just give you an example. 7 4s are 28, take away 21, that will give you 7. 3 4s are 12, take away 5 would also give you 7. So that's how you can check your answer and you know you've got that one correct. Expand and simplify, nice and easy again this one. Is what I call the smiley face method. Some people call it the FOIL method, but you multiply everything by everything else. So 2x times x is 2x squared. Positive 3 times negative 8 is negative 24. Positive 3 times x is positive 3x. And 2x times negative 8 is minus 16x. So 2x squared. Positive 3x, take away 16x will give you negative 13x. Basically 3 take away 16. Or negative 16, add 3, either way. And then there's minus 24. 2 marks for that. You should be getting that mark. Solve this one. A bit of a tricky one, this one, but anyway. That falls, you want to get f on its own basically, so find the value of f. That falls on the bottom. So it's being divided by 4. How do you want to do divide by 4? Well, you multiply by 4. So that's why it gives you 7 take 3f equals 8, because 2 times 4 is 8. I wanted to get rid of that negative 3f, because it was irritating me. I don't like having the thing you're trying to find as a negative. So that's why I've added 3f to both sides. Then want to get the f's on their own. So I've got rid of this 8. So that leaves me with minus 1 equals 3x. Then I've divided, want to get f on its own, so divided both sides by 3. So that will leave f on its own. But minus 1 divided by 3 is just minus 1 over 3. So minus a third. Question 13, over the page. There you go. Express 180 as a product of its prime factors. You just draw a factor tree. There's other ways of doing it. You could have done 2 and 90, for example, at the beginning. But I thought that was the easiest way. You can either give your answer as 2 times 2 times 3 times 3 times 5, or you can give it in as index notation, which is there. Either answer is fine, but it's a nice, easy 3 marks. The one underneath was a bit trickier, I thought. I've not seen many questions like this. Martin thinks of 2 numbers. The highest common factor of my two numbers is 6. The lowest common multiple of my two numbers is a multiple of 15. So what I've done, I've worked it out, but I've tried to explain it at the same time. The highest common factor, so the highest number that goes into the two numbers I'm looking for. So that means 6 must go into these two numbers. So for example, it could be 12 and 18, because 6 goes into 12 and 18. So I put a few lists there, a bit of a list there. The lowest common multiple, the lowest number my two numbers go into. So if it was 12 and 18, what's the lowest number they would go into? Well, it'd be 36. But anyway. So it's got the lowest number they go into is a multiple of 15. So it's either that one, that one, that one, that one, or that one. There's a few answers to this. I got 6 and 30, because 6 goes into 6, it also goes into 30. And 6 and 30 also go up into 30 there. So that works out quite nicely. Just having a look to see which other ones you could have had there as well. Maybe 12 and the 30 you could have had. Yeah, 12 and 30, because they both go into 60. There's a few different combinations, and that's a bit of a nasty question. Right, moving on. Okay, Susha has a full 600 millilitre bottle of wallpaper remover. She's going to mix some of the wallpaper remover with water. Here's information, blah, blah, blah. She's going to use 750 millilitres of water. How many millilitres of wallpaper remover should she use? So it says here, wallpaper remover, 600 millilitres, mix a quarter of the wallpaper remover with 500 mils of water. So a quarter of the wallpaper remover is 150 millilitres. So that's how I've got that. And that equals 4,500 millilitres. So this top bit I've just taken exactly from here. So what I'm going to try and do is get this 4,500 down to 750. So I'm going to have a bit of a play with it. What I did first of all, I noticed you could divide both by 3. So I found out that 50 millilitres, because I divided that by 3, or find a third of it, whichever way, equals that many millilitres. And looking at that one, well, to get from there to 750, I've only got to half it. So there you go, divided it by 2. So 25 millilitres equals 750 millilitres of water. So she should use 25 millilitres of wallpaper remover. I hope that one's clear enough. Next one. Box plot. The students in a class kept a record of the amount of time in minutes they spent doing homework last week. The table shows information about the amount of time the girls spent doing homework last week. There you go, there's that. On the grid, draw a box plot for this information. Well, the least amount of time was 60 minutes. So that's why that goes in there, 60 minutes. Careful, it goes up in 5s here, so a little bit careful when you read the scale. I will zoom in on this box plot in a minute so you can see it. The range is the difference between the smallest and the biggest. So if that's 60, then the highest must be add on 230, so 290, which is why that one's there. The median is 170, so that's there. The lower quartile is 100, and the upper quartile is 220, so that one's there. I'll zoom in case you want to pause that and see exactly what I've done. Okay. The box plot below shows information about the amount of time boys spent doing homework. Compare them. This comes up loads, and there's basically two things you've got to say. You've got to say who spends longer doing homework, and you can compare that with the median average. So in this one, I put on average boys spend longer doing homework, but you've got to say how do you know this? We know this because their median average is higher. So that's 190 compared to 170 for girls. So actually quote figures is quite nice. The other thing you've got to compare is the measure of spread. So that's how far spread out the data is. You can either look at the range or the interquartile range. I think the interquartile range is a better one to look at. The boys have a smaller interquartile range. That's from here to here, compared to the girls, which is from there to there. I've even compared it, look, 100 minutes to 120 minutes. This means the amount of time boys spent on homework is more consistent. So the girls is quite spread out, because that's 50% of your data is in here. So 50% of the girls are in here, but 50% of the boys are in here. So the time boys spend doing their homework is more consistent than the time girls spend doing their homework. Next one, question 16. There are 200 workers at a factory. The cumulative frequency table. Okay, on the on the grid opposite, draw a cumulative frequency graph for this information. So this is where you've got to plot 20 against 25, 30 against 70. Quite often they ask you to calculate this by just giving you the frequency, then you have to work this bit out, but they've given it to you, so that's nice. So I'll quickly show you what I've drawn on the other page. This is probably the two easiest marks in the paper, I think. All I've done is plotted that point, 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 and then you've got to connect them up with a curved line, so don't use a ruler, so do it freehand. The mark scheme says it must go through all your points and it must follow the general trend of the line. To be fair, if it's between that one and that one, it's a bit fiddly. You probably can use a ruler and get away with that because they probably wouldn't notice. But anyway, make sure it's a nice cross you do it with, and always do it in pencil. I've used a pen here just so it shows up better on the screen for you. The next question says, Graham says 10% of the workers at the factory are older than 65 years old. Is he correct? Well, that's why I've got 65 marked down here, which I'll quickly zoom in and show you. So there's the age, look at the bottom. And that's where the 65 is. So what I've done, I've drawn up, and I've hit my cumulative frequency line, and then I've gone across. So let's see where I go across to. So there we go. You go across to 190. So that means there's 10 workers older than 65. There's 10 workers older than 65. So Graham says 10% of the workers are older than 65. Is he correct? And the answer is no, he's not correct. Because it's that 10 workers are older than 65, but 10 out of your 200 workers is only 5%. So no, he is wrong, but you must give an explanation like that. Simply writing no will not get you the marks. Just incidentally, this is one of the very few questions on cumulative frequency that I've seen. It's not required you to calculate the median. So it just goes to show you that you're not always expected to do it. To be fair, you normally are, but in this one you're not. Right, this one is a bit fiddly. And there's different ways of answering it. You could do external angles or all sorts of things. The way I teach it, I've got kind of like a stock way of getting any one of these correct, and I think it's quite a logical way of doing it. But let's have a look anyway. It's a regular octagon, so that means all the angles and all the lengths of the sides are equal. So there's your regular octagon. Work out the size of KFE. So KFE is there. So you need to work out the size of this angle here. And it looks like an absolute nightmare. And to be fair, it is quite a tricky question. But we're going to see if we can work it out together. What I've done, I've made a triangle here. And I'm going to zoom in on what I've done and just talk to you about it a little bit. I've drawn a straight line from this point C down to point F. And you can see that's an isosceles triangle because these 2 points here are the same, and it says so in the question. So I know there's 180 degrees in a triangle, so that means there's 40 degrees left, and as these two are the same, they must add up to 20 degrees each. So that's 20 degrees each, which is quite nice. This is a right angle here, so that's obviously 90 degrees. So I already know I've got 110. So I could work this one out, but I don't know this angle here, the interior angle of an octagon. So the way I teach that, and I'll quickly show you down here. In a triangle, there's obviously 380 degrees. No, sorry, tell a lie. In a triangle, there's 180 degrees. In a quadrilateral, so square rectangle, it's 360. And the trick is it goes up in 150 each time. So inside that octagon, there's 1,080 degrees in total. All I've done is gone up in 180s each time. Not done anything special there. So if there's 1,080 degrees in the whole lot, to work out what the size of each one of these angles is, you simply divide it by 8, because there's 8 different angles. So there you go, I've done it there, bit of long division. So each angle is 135, that's 135, and so on. So I now, for this one, I've done my isosceles triangle bits, I know that's 20. I know that's a right angle, so you do 135, take away the right angle, take away 20, and it gives you 25 degrees. And that's your answer for 4 marks. If you look at that and really don't have a clue at where to start, because that is a very, I think, challenging question to get started on, see what marks you can get out of it. So for example, it's going to be something to do with these lines here, they are the same length, so just make an isosceles triangle and get that those two are 20, you'll get a mark for that. But it's all about picking up the marks you can if you're not sure how to approach questions like that. You might then notice that that's a right angle as well, so if you get that in and mention that, you might get another mark for that as well. Okay, question 18. A, B, C, D and A, E, F, G are mathematically similar trapeziums. That means that all the side lengths are related to each other. So for example, to go from 12 to 18, you times by 1.5. So that means you times 5 by 1.5 to get the length of AB, this side here. That's what similar shapes mean. In this case, that's actually what they're asking you to do in the very first question. So you notice that from 12 to 18, you either half 12 and add it on, or you times it by 1.5. So you do the same thing here. You half 5, which is 2.5, then add it on, so that'd be 7.5, or you can just do 5 times 1.5, because that's your scale factor, and that will get you the mark. The one underneath is a lot trickier. It says triangle AEFG has an area of 36 centimetres squared, so I've written that on. And it says calculate the area of the shaded region. So first of all, you want to find the area of the whole trapezium, the big one, and then you take the 36 off. And I'm going to explain a little bit to you here about the how similar shapes work with area and things like that. To go from a length to a length, in this shape above, you times it by 1.5. And we've already explored that from going to 12 to 18. You times it by 1.5. That's in one dimension. It's just a length, so you times it by just 1.5. To go from an area to an area, you actually times it by 1.5 squared, because there's 2 dimensions there. And for volume, you cube it, because there's 3 dimensions. So your scale factor here, to go from an area to an area, because remember you're going to go from 36 up to the big one, isn't times it by 1.5, it's timesing it by 1.5 squared. And 1.5 squared is 2.25. I worked that out because I know 15 squared is 225, and I put my decimal point in the correct place. 2.25 is actually 2.25, and bearing in mind it's a non-calculator paper, it might make it a little bit easier to do this sum. So 36, because that's the area of the small white trapezium, times 2.25 or 2.25. Well, I've just done 2 of them and a quarter of it, gives you 81. So 81 is the area of the big trapezium, but then it only wants the area of the shaded bits. You need to take out this 36. So I've done 81, take away 36, which gives you 45 centimetres squared. Nasty one, that one. Moving on. Complete the table of values for y equals 4 divided by x. This is a nasty one, but we'll go through it. 4 divided by 8, well 4 over 8, if you want, look, write it as a fraction. 4 over 8 you need to recognise is a half because you simplify it, so that will give you 0.5. 4 over 5, that's 4/5, it's 0.8. If you're getting up to this question doing well, you need to recognise that. 4 divided by 4 is 1, 4 divided by 2 is 2, 4 divided by 1 is 4, and this one, 4 divided by a half, well how many halves go into 4? It's 8. So you get 2 marks for getting all of those. If you get down the ones you can if you're not sure. And the next thing is just plotting them. So the first one is 8, 0.5, so look, I'll just zoom out a little bit. So you go along 8 and up 0.5, then 5, 0.8, along 5, up 0.8, and so on, and you'll get a nice little curve that looks a little bit like that, and that will give you 2 marks. Again, in the exam, use a pencil for that one. But if you follow the rules we do for linear, well, I say not actually a linear graph, there's a bit of division going on, but for these sorts of graphs, you shouldn't go wrong with it. Just adapt the knowledge you already know. Right, the solid shape is made from a cylinder and a hemisphere. Cylinder is like a baked bean tin, and a hemisphere is well, it's half a sphere basically. So it's like a football chopped in half. The radius of the cylinder is equal to the radius of the hemisphere. Well, that sort of makes sense because the radius is there and it comes out, and it doesn't look as if it doesn't overlap. You can clearly see that. The cylinder height is 10 centimetres, good. Curved surface area of the hemisphere is 32 pi. That's the curved surface bit we can see on top. Work out the total surface area of the solid shape and give your answer in terms of pi. This is really difficult, I think, but I'm going to talk you through it. The surface area of a sphere, and this is given to you in the front of your exam paper, is 4 pi r squared. And let me show you what that is. There you go. Surface area of a sphere. I'll zoom in for you. There you go, 4 pi r squared. There you go. All I've done when I've done it, I've just put the times signs in to make it a little bit simpler. So there we go. So the surface area of a hemisphere, because it's half of it, is going to be half of that. So I've halved it because I've just halved the 4 to a 2. So that's how I've got that. So we're told the curved surface area of the hemisphere is 32 pi. So the surface area of the hemisphere is 32 pi. So that equals 2 times pi times the radius squared. And we're trying to work out what the radius is here, because if we can find the radius of this, we can work out the radius of the cylinder, and then we can start working some stuff out from there. So 2 pi times what will give you 32? Well, it's times 16. So r squared is 16. So you need to square root it. That means r is just 4. So the radius is 4 centimetres, and we can put that on, 4 centimetres. Next thing, bear in mind, we've got to do surface area. The next thing I did was work out the area of the circle on the bottom. So area of a circle is pi times the radius squared. So I'll quickly show my workings. There you go, look. Pi times the radius squared, so it's pi times 4 squared, which is 16 pi. Quite a nice one, that one. And the curved, by the way, if you only get this far and you can't do the rest of it, that's fine, you still get marks for it, because there's 5 marks for this question. The area of the curved surface of the cylinder, so that's the bit that goes round the outside. To get that, you've got the height, which is nice, but you need to work out, and I'm going to draw it on, the length here, all the way around the outside, because if you unfolded that, it'd actually be a rectangle, and 10 is the height, and if you imagine that came out and went over there, that length there would be the width, and that is actually the circumference of that circle. So circumference is pi times diameter, so it's pi times 8, because if the radius is 4, the diameter's got to be 8, so that'd be 8 pi. So the area of that rectangle is 8 pi times the height, which is 10, which is 80 pi. So your final answer, the total surface area is 32 pi, which is the area of the curved bit on top. The 16 pi is the area of the circle on the bottom, and the 80 pi is the curved surface area of the cylinder. Add them all up, you get 128 pi. Not an easy question, that one at all, so well done if you got that one. Next one, question 21. Bit of work on surds. Give your answer in the form a plus b root 2, where a and b are integers. An integer is a whole number, if you weren't sure. All I've done is double brackets, so you multiply out the double brackets, so I'll talk you through it. 1 times 3 is 3. Do the signs in a minute. Root 2 times root 2, so square root of 2 times the square root of 2, well, it's actually 2, because you're timesing it by itself. Because it's a positive times a negative, it becomes negative 2. Root 2 times 3, well, it's 3 root 2, or 3 times root 2, and that's positive, because they're both positive. And the last one is 1 times root 2 is root 2, or you could write 1 root 2 if you want, but there's not a lot of point. And because one's positive and one's negative, it's negative root 2. So what we can do is simplify it a little bit here. 3 take away your 2, it's just a 1. And if you've got 3 lots of root 2, take away 1 lot of root 2, that'll give you 2 lots of root 2. So it's 1 add 2 root 2, and that fits in with how they had up there. 2 marks for all that, which isn't a lot, but I suppose it's worth having. Okay, the next one, question 22. Simplify fully 3a to the power... Oh, that's my pen, excuse me. Okay, question 22. Simplify fully 3e to the power 0. Anything to the power 0 is always 1. You need to know that. Next one. Simplify fully this. Okay, I'll talk you through it. This one to the power negative a half. Ignore the negative, we'll deal with that in a second. To the power of a half means square root. So you've got a square root at the top and square root at the bottom. So the square root of 64 is 8. The square root of x to the power 6 is x to the power 3. Because when you square root an index number, you're only halving it. And that's why I've got the bottom one. 25 square rooted is 5. Y squared square rooted is just y. Or y to the power 1, but I don't know why you'd do that. The negative means give the reciprocal. So it goes from 8x cubed over 5y to 5y over 8x cubed. So you flip it upside down, and that's how you do that. Even if you just do the square root and bit, you'll still get one mark for it. Right, the next one. Write 5 over x take 3. Take away 4 over x, add 3 as a fraction in its simplest form. All right. When you do any subtraction with a fraction, what you've got to do is get the bottom number the same. So what does x take 3 and x add 3 go into? you know, it's a bit tricky when it's with algebra. What you can do is just cross multiply. So I've times the bottom bit here by, well, both sides, top and bottom, by x add 3, because it comes from there. And the x take away 3, I've times this side because it comes from here. X add 3 times x take away 3, I've actually done over here, look. X take away 3, x add 3, multiply it in double brackets. I'll zoom in so you can see it. I'm not going to talk you through multiplying out double brackets, because if you've got to this stage you should know how to do it. It leaves you with x squared take away 9. So the bottom number becomes x squared take away 9. The top number, well, 5 lots of x add 3 is 5x add 15. And this one is 4x take 12, which is there. You then do your subtraction. So you've got 5x take 4x is x. And this is the tricky bit. Positive 15 take away negative 12. And take away a negative means add. So that's why it's x add 27 over x squared take 9. And that is the answer. I'll show you the answer there, but it's the same as what it is here. So that's how you do that one. Right, moving on. Probability trees is the next one. I've actually had to do this on a separate bit of paper because I thought this was a very nasty question. I'll read you the question, I'll show you my workings for it. Paul has 8 cards, so there's a 2, 3, 3, 4, 5, 5, 5, 5. There's a number on each card. He takes at random 3 of the cards. So if he's taken 3 at random, he's not going to replace them. So for example, if he takes a 2, first of all, he can't take another 2 because there's only one of them there. He adds together the total of the 3 numbers to get a total t. So what is the probability that t is an odd number? So what it's saying is if he picks up 3 cards at random, what's the probability it's going to be odd? There's probably lots of very clever ways of doing this. You can work through the combination you could have that can make it odd. You can recognise that to get an odd number, what you need to add together and all the rest of it. I actually started doing a probability tree here and it didn't fit. So on a spare bit of paper, and this did take me a very long time, I'm going to show it to you, I drew a probability tree, and I'm going to talk you through it very briefly, but there's an awful lot of information on it. This is what you'd have to do if you wanted to do a probability tree for it. And I, be honest, I wouldn't recommend doing this in an exam, because it's very, very time consuming. You know, I'll zoom in and I'll go through it so you can have a clear look at what I've done if you like. The answer is 156 over 336, sorry, we're just looking for the answer. I thought it was a bit of a naughty question because I think it's a really good skill being able to draw a probability tree. And I think they've made it, Alex, I've been a bit naughty, they've made it very difficult for you to do that. But anyway, here we go. So first ones you could pick a 2, 3, 4 and a 5. There's my probabilities there. I'm not going to bore you with it because it's fairly simple. There you go. Right, so if you're taking a 2 first, and I've had to trim this down a little bit. If you take a 2 first, you can't take a 2 again because there's only one of them there. So there's only 7 cards left, so blah, 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 blah. So that is that. Then you can take the following cards after it. Then I've done all that for all of them. I'm going to quickly sort of scan up it now to see if that makes any sense for you. Is there does this one work? Yeah, that works, although it will take ages, so I'll just do it with my hand. So that's all the workings I've done for it there. Then I've worked out which ones at the end add up to be an odd number, so that's why you can see all these numbers I've put down. Well, I actually added them all up. There you go. But then I've only worked out the odd one. So I've worked out that one. The 9 is odd, 11's odd, 13's odd, 9 is odd. Multiplied across, added them all up, and I got to 156 out of 336. I think that's a very nasty question. But anyway, there we go. Right, next one. Question 24. Let's have a look. A is a point with the coordinates 1, 3, okay? And B is a coordinates with a point 4, -1, and a straight line goes through A and B. So imagine you've got your, there you go, you'll have something like this, wouldn't you? 1, 3 is roughly there, isn't it? Let's go for about there. And 4 -1 is roughly there. So it's saying you've got a straight line that goes through those 2 points. All right, there you go. Is the line with the equation 2x equals 2y, equals 3x take 4 perpendicular to line L? Well, if it's going to be perpendicular, it means it's going to go through it at 90 degrees. So it's going to go through it there or something like that, to make a right angle. What you need to do is calculate the gradient of this line here. And to calculate the gradient, it's a difference in the y-axis divided by the difference in the x-axis. The difference in the y-axis, because that's the first one, is 4 and minus 1. Difference there is 3 and minus 1. Difference is 4. Difference in the x-axis is 3, so it's 4 over 3, so it's 4 thirds. Because it's sloping downwards, it's actually negative 4 thirds, or negative 4 over 3, because you're working it out this way. There we go. So the gradient, so that's the gradient of the line we've just drawn, minus 4 thirds. So for it to be perpendicular, the gradient is going to have to be, you can flip that over, it's a reciprocal, 3/4, so positive 3/4. So let's have a look. Oh, there you go, I've written it there. So what I've done, I've divided through by 2 to make it easier. So that gives you y equals 2/3 x, take away 4, because I've halved everything. Obviously a half of y equals 3 over 2x, so 3/2 of x, take away 2. Half of 3 is 1.5. So you could have y equals 1.5x, take 2, but it's the same thing, 3/2. So no, it is not perpendicular, because this would have to be 3/4 for it to be perpendicular, and it's only, well, it's actually 1.5 or 3/2. So the answer is no. Bit of a nasty one, that. Okay, and lastly, question 25. The diagram shows part of the curve of the equation y equals fx, the function of x. The coordinates of the minimum point of the curve area are 3 minus 4, which are there. Write down the coordinates of the minimum points with the equations below. So you want the minimum point. So y equals fx add 3. That add 3 means that it gets shifted up 3 spaces. So that minimum point will go to there, and the coordinates of that point are actually 3 minus 1. That's why it's 3 minus 1. The next one, y equals a function of 2x. Well, the function of 2x, because it's in brackets there, means it's been stretched along the x-axis. So it's quite difficult to explain, but imagine it's been, from the middle bit, it's been stretched like that, if you like. But because it's just this side of it, this will stretch along that way. So it goes halfway back towards the x-axis. So that's why it's 1.5 minus 4. It's quite tricky to explain. Look it up if you like. And the bottom one, y equals f of negative x. So that's when basically the values of x have become negative. So it's minus 3 minus 4. So that would be over here, minus 3 minus 4. And that would be down there. The rough grade boundaries for this paper is obviously out of 100. To get D, you're looking at around sort of 20-ish. To get a C, I think it was around 29, 30. To get a B, usually I say 50, but I think it's around 48 on this one. An A, I think is roughly 66, and an A star is roughly 84, 85. Hope you did well.